In today's tutorial, I am going to show you how to split or subset VCFs, and the criteria we are going to use is sample IDs. So let's get started. So let me say that the commands for this tutorial are all available. So if you want all of them, I've packaged all of them into a single bash script. So if you want them, just check the description box. The link to the file is there. Now let's proceed. So there's the PC requirements. We are going to use BCFTOOLS to do this, by the way, and so you need to make sure you have BCFTOOLS installed. That's the only thing you need. I have instructions for installing BCFTOOLS, so check the description. You'll find the link to the video. So with BCFTOOLS, you can use Conda, Mamba, or Micromamba. You can also install using by building from source. That's also another way to do that as well. So just check the description where you find links to the different approaches for installing BCFTOOLS. All right, now let's get started. So let's open a terminal and then start the exercise. All right, so we are on the terminal now. So what I'll do first is to create a working directory and I'll cd into it. So I'll say make the VCFs and I'll cd into it. So this is my working directory. Now I'm going to download the example data. So I have it on one of my GitHub repos. So I'll go there. Let's check the repo. So this is the repo. All right, this is the file we use. So I will leave the link to this page in the description box. I repeat, I will leave the link to this page in the description box. So when you are here, check this file, variants_1k.vcf.gz. This file is what we are going to use. I subsampled a VCF for the 1000 Genomes project. So that's what I had. So to download, just click it and you'll be sent to another page here. You will see something like this. So come to this side. All right, so you will see this download button. So you can click it to download. Or you can also come to raw, right click, and then go to copy link to copy the link, and you can download on the terminal. All right, so that's what I'll do. So I'll move to the terminal and then I'll download it. So I'll use wget and I'll paste the link. I'll also paste this link in the description box. So you don't even need to go to the GitHub repo. You can just use that link that I'll give in the description box to download it directly. So let's download the file. All right, the file is being downloaded. So let's wait for everything to get done for us. All right, the file has been downloaded. So let's take a look at it. Let's do an ls and we are going to find the file here. So this is what we are going to use. All right, now let's start. Now we are going to start with the splitting. So splitting in this tutorial, I mean all the samples in your VCF files. Okay, all the samples in the you want to split, you want to get the variant for all the samples in separate files. Now let's take a look at this. Let's first look at the sample IDs. Okay, so to use BCF to do that, we can say BCFTOOLS and we can say query-l and you specify the VCF file. So when you execute this command like this, you will get the samples, the sample IDs or sample names, whatever you want to call it. That's fine. It's up to you. All right. Now with the splitting, what we are going to do, we are going to get the variant for each of these samples, all the samples here. And we are going to place them in separate files, separate output files. So we have a file for this sample, a file for this, a file for this, a file for this. So you have all of them in separate files. That's what we are going to do next. And I want you to watch this video to the end because I'll give an important detail getting to the end of this video. All right, so just make sure to watch till the end. It's very important because sometimes we forget to include that when we are doing the splitting or subsetting. So I'll let you know that later on. Okay, so we have our samples here. Now, to do the splitting and get the variant for each sample in a separate file, we will use the BCFTOOLS plugin called +split. That's what we are going to use. Let me send you to the page where you can read more about it. So just come to this side. The plugins, it has the information for all of them. We'll use the +split. I'll put it on the terminal, by the way, so don't worry. I will leave the link to this page also in the description box, so don't worry. So let's look at it. So to use the +split, you also have to specify a file which has the samples you want to split. All right. So that's what we need to do next. So that's what we are going to do. So we are going to say We are going to reissue this command again, and then we are going to place all our files in it. I mean, not files per se. We are going to place all our sample IDs in it, and then we will use the BCFTOOLS plus splits. Okay. Before I even do that, let me just do it for you to see. Let's say BCFTOOLS plus splits. So this is the utility we are going to use. So if I issue BCFTOOLS like this and I issue the plus split, I'll get the help command to tell you how it's used. Basically, so this is what we are going to do. Now let's proceed. Let's clear the screen and continue. So let's reissue the command first again. We have a VCF file here. So let's first reissue the command to get our sample IDs, and then we will save them to a text file. So I'll just record the command again here. All right. And I'll bring my greater than symbol like this, and I'll say sample IDs. Or I can even say all samples. Let me say all samples. I mean, it depends on what you want. All right. So you just have to guess the right name that you want. For now, I just think sample IDs would be better. So I'll say all sample IDs like this .txt. And then I'll save it. So I'll do an ls. I'll find a file there. So I will just do a cat to display it. Sometimes I do it to verify some stuff. So I have them there. Before I even proceed, we can even count the number of samples. So I can say wc-l, say all sample IDs.txt. So this will give me the number of samples. I have 11. All right. Sometimes you can also do that to just start exploring your data, but that's fine. So let's proceed. I'll clear the screen. I'll do an ls. So I have my VCF file. I have the samples of interest. Now it's all the samples. So I have them here. And so what I want to do is I want to get the variant for each of the samples to a different file, an output file, a different output file. So that's what I'm going to do. Now, before I call BCFTOOLS to do the splitting, I will need to index the VCF file. So the one here, I'll index it. So I'll say BCFTOOLS index. Now I'll specify the file name. So let's index this file. Now in the indexing, there are other ways to do it as well, but I'll use just this one here. All right. So if I do an ls, I'll find another file, which is .csi. That's the index. So now we can proceed. So now we are going to do the splitting. So I'll do this. I'll say BCFTOOLS, and then I'll say plus splits like this. Take note of it. So plus and then splits. It's one word. Space, and then I'll say -s, and I'll specify the file which has the sample IDs like this. And after that, I'll do this. I'll specify the VCF file, the one that we are going to extract the information from. So that is variant 1k.vcf.gz. And then I'll specify an output format. So I'll say -o, uppercase O, and then Z. So I want vcf.gz. That's the format I want. I want it to be compressed just like this one here. So that's what this one is for. And then I'll say -o. Now here the -o represents a directory. All right. So I'll say split. You don't need to create that directory. All right. So BCFTOOLS will create it for you automatically. So I'll say -o, and I'll specify split. So this directory is going to be created, and I'll have all the files in it. Okay. So this will be the final command to do the splitting. So let's execute this command. All right. So it's working now. So it should take roughly about a minute or less. So let's wait for everything to get done for us. Okay, so the variants have been extracted for us. So if you do an ls, you'll find a directory called split. So when you ls into it, you'll find your files, the individual samples here. All right, so all of them, and you also have the variants. So this is how we do it. Now, let's take a look at something here. This is very important. You should always make sure you apply it or do it, depending on what you have. You may be dealing with raw VCF files or VCF files that have already been processed. No matter the situation, there is something you need to also check. Now, let's take a look at one of the samples, for example. We have it here. Let's count the number of variants in this sample. All right. Now, I'll say there are different approaches to do it, but I think I'll just use the Linux command to do, or let's just use the BCFTOOLS. That should be much better. So either BCFTOOLS or Linux, any of them is fine. So I'll use the BCFTOOLS command to do that. But I repeat, you can still use Linux to do it, but because we are using BCFTOOLS, I want us to be consistent so that beginners don't get confused. So I'll say BCFTOOLS view, and then I'll specify that variant. So that file. So it's supposed to be in split slash this 00096 like this. And then I'll bring a pipe and I'll say grep dash vin dash c. It's vin dash c. I bring a quote, a caret symbol, and a hash. And I bring another quote again. It's all single quotes. So let's execute this command. So you'll see this number here. We have 922022. Now let's also get the number of variants for this sample. Let's take another sample. Yeah, this one should be fine. All right. So when you come here, let me just clean it so that we can do it fast here. So let's record the command. Let's specify this time this sample, this one here. You can try with another sample too. That's fine. Then we bring our grep. I'll just copy and paste this one there to be fast. And then I'll execute this command. Yeah, so that's what I'm talking about. So you realize that when we counted the number of variants for this sample and for this sample, it's showing the same number. All right, so it's the same number that will be shown for each of these samples. So that is what I want you to pay attention to. All right, you can have this situation, all right, but if you are not aware, you may think you have extracted your variance, so that is it. All right. So this number here comprises of the variants as well as non-variants. And so if you want the variant, then you have to issue the BCFTOOLS view command and add some additional options to it. So that's what we are going to do next. So we are going to use an example here. So we will use one sample here. So let's say we want the variant for this sample. That's how we do it. Now we have done a split, so we have our individual files, all right, i.e. individual samples. So if let's say we want the variant for this sample, that's how we do it. We say BCFTOOLS view, and then I'll specify the VCF. All right, so I'll say split slash, and I specify the VCF file. And then I'll say dash C1. I'll talk about the C1 later. I'll indicate dash OZ, and I'll say dash O, and I'll specify the output file name. So this O here is a file, not a directory. All right. It's different from the plus split one. So this one is a file itself. So I'll just paste the sample ID, and I'll say dot, let's just say true variants vcf.gz. So let's execute this command. All right, so we have done that. So if I do an ls, I'll find a file with the name here. Now let's get the number of variant for this file. So I'll say bcftools view. Let me use it here. It's view. So it's bcftools view, and then I'll specify the file, which is this one, and I'll bring my grep command, which is this. I'll just do a copy and paste here. It's already here, and then I'll paste it. So let's execute this command. All right, so you see what has happened here. So there's the number of variant for that sample. All right, now The reason why I was able to get this is because I used the flag here, that's C1. Now that C1, I use this because it gives me the same output as using the GATK select variants command. All right, so I have the GATK command here. Let's check. This is the page. You can read more about it. So the GATK select variant can also be used to subset VCFs or split VCFs. And so I realized that when I use that C1 flag for BCFTOOLS, I get the same result. All right, you can read more about this flag here, this option here. You can read more by visiting the BCFTOOLS page here. So when you are here, scroll down to this side, check for the view command, click it. And when you are here, scroll down a bit and you will see it there. So we have it, that C and then that C, lowercase and uppercase. I use the lowercase one. So you can read more about this and then decide if it works for you or not. All right, so that's what I do. But for the most part, that one works for me. So that's why I use it. All right, so that's what we have. So what we've done is to get the variant for one sample. You know, we had it already splitted. All right, so this is just one sample, but you have multiple samples in some situations. All right, so how do we do that? That's what we are going to take a look at next. So what we are going to do next, we don't need the splits again. We will just use the BCFTOOLS view command directly and then get the variants themselves and place them in separate files. So that's what we are going to do next. So let's proceed. So I'll clear the screen and then I'll do an ls just to take a look at my files again, and then I'll proceed. So I'll have my ls also here to look into the splits directory. So I have everything I need. So what we are going to do next is to write a bash script to do this. And for this part of the tutorial, I'll focus on just 3 samples, a few of them. But if you have lots of samples, you can always contact me and then I'll show you what to do next. So let's just do a head and 3 into the all sample site.txt. I'll need this one here. So I just want to focus on just this one here. But in principle, what I'm going to do, you can still use it on multiple samples. It doesn't have to be 3. Hundreds or thousands, you can still use it. You just have to know the principle behind it. All right, so I'll just focus on just 3 samples here. So I'll write a loop, and then that loop will take each of these sample IDs and then do the extraction for me. So that's what I'm going to do next. So I'll just say nano, and I'll say extract.sh, or I can say extract variants. Let me just put it that way. I want it to be descriptive. So extract variants.sh, and then I'll open it. All right, so that's what I'm going to do. So I have 3 samples. Let me just do it here. Let's display them again. I have 3 samples, so I'll copy all of them here. I'm going to write a loop, so I need that information. So first of all, I'll do this. Let me just bring my shebang line. And then the next line, I'll proceed. So that's what I'll do. I'll say for sample in. All right, that's what I'm going to do. For sample in, and then I'll just copy them. I'll just copy them here. For sample in, let me paste them one by one. It should be faster that way. So I'll just paste them, each of them separated by a space character. So I have 3 samples here. All right, so this is the loop for sample in, and I have my list here. Okay, so I have 3 samples. So this is the structure of the loop. And then in the next line, I'll say do. And then the next line, this is where the processing takes place. So I can say BCFTOOLS view, and then I'll specify the main VCF file. All right, and I also specify the sample. There are 2 things here. So when you use the BCFTOOLS view command, you need to specify the sample that you want to use, or you want to subset. All right, so this time we have 3 samples, so you specify all of them here. Okay, in separate commands. That's why we have the loop. So don't worry, you'll get a hang of it when I start. So I'll say BCFTOOLS view, and I'll say -s like this to represent a sample, and I'll say $sample. And then I'll bring the main VCF file, the one which has the information, or the information, which is this one here. Let's do an ls, this one here. All right, I'll need it. So I'll just specify that that's what I need. And then when you come here, this is where I bring the -c1. And I'll specify -o, like this -o. Let me just put it here, -o. So this is for the output format. We want vcf.gz, and then space, and I'll say -o again, space, and here I'll specify an output name. All right, so for the output name, it also has to be descriptive. All right, so that one, the name, it depends on what you want, but I'll give an example here. You have to use a naming convention that works for you. All right, so I will just use a different approach here. So I'll just say, I'll bring a double quote first, and I'll say $sample, and I'll bring a double quotes, and I'll say .variant.vcf.gz. This will be the name, the output name, the file name. Let me put it that way, the output file name. Okay, and then I'll bring down here. Now, there's something else I would like us to add. Sometimes when you are issuing your command, you would like to know what is happening, or you would like to know what file or what sample is being processed. So this command here, we will just add something here. I will say echo. I'll bring a double quote, and I'll say processing, and I'll say $sample. You can also experiment by adding other characters as well here. It's up to you. It's time to get creative. So you can just do that. Just go all out. It's fine. So you can do something like this. All right. And then you can edit and save changes. And after that, you can do an ls. You find your bash script, which is this one here. So let's add execution right. So I'll say chmod +x, and I'll specify the file like this. All right. So now let's execute the bash script. So I'll say // and I'll say extract variant.sh. You can also use bash extract _ variant.sh, but for this tutorial, I'll just use this one here, // and I'll specify the file. So let's execute this command. So when you do it, you'll see this notification telling you that it's processing a particular sample. So we have all the samples being processed for us. All right, so this is what we have. So let's wait for everything to get done for us. All right, so everything has been done. So if you do an ls now, let's do it. You'll find your files. All right. Okay, so you see them. Now I'll show you something else. When you are working in a Linux environment, it's likely you will generate lots of files. So this is where a good naming convention comes in. When we open the bash script, let's just open it here. I will do it here. With the output file, we said the output files will have the sample id.variant.vcf.gz. All right. So if you have multiple files, then you can just issue a command to display just those ones. Let's do that now. So let's say ls star.variant.vcf.gz. So this will display just those files for you. All right, that's what I thought I would bring to your attention. Let's do an ls to get back all our files. So now let's compare the variants in the split directory to what we have here. I mean, we did it, but let's do it again. This time, let's use a different sample. So let's say we have this one here, or you can even use this one. You can use any sample of your choice, it's fine. So I'll say bcfTOOLS view. All right. We are dealing with individual samples here, so we don't need a -s. Okay, so I'll say bcfTOOLS view, and then I'll do this. I'll specify split / and then I'll specify the VCF file. I bring my grep dash vin dash C. I bring my pattern. And by the way, I've covered a separate tutorial where I explain everything in details about how to count variants using Linux commands and BCFTOOLs. So if you don't understand anything here, just watch that video. The link to that video is in the description box. All right, so there's it. So let's count the sample here. We should get 9 something because that's what we got for the others. So we'll get something similar. And then let's also do for what we have now. That is this current one here. So I'll just copy and paste. Yeah. So BCFTOOLS view. And then I bring my grep. I'll just do a copy and paste. And I'll execute the command. So this will give me this one here. So you see the difference that we have. So this is how we do the splitting for individual files and get the variants. But if you just want all the variants, then you can just use the BCFTOOLS plus place to get it. But whatever the case, it depends on what you want at the end of the day. So I'm showing all the options available so that you can use the one that is okay for you. So that's how we do it. All right. Now, if you want just a single sample to, then that one you don't need the loop. We had this loop to do the extraction for us. All right. But if you just want a single sample, then you don't need to write all this. Then you can just use this BCFTOOLS view command. All right. So let's try with a different sample tool to see. This time, let's say tail all sample IDs. Let's use a different sample here. So let's say we want to subset this one here. All right. I'll just copy. I'll just do it this way. Let me just reissue this command. So if let's say I want this sample, I think I copy one of them anyway. Any of them is fine. Let's say I want this sample. All right, I want this sample. Then I'll just say BCFTOOLS view, and I'll say -s, and I'll paste that sample of interest. You can also do more than one sample, by the way, but for now we are just using one sample, so that's what I want to show you. So one sample, and then you specify the variants where you want to extract the information from. Then you can bring your -oz and -o, and you specify the sample ID here. All right, like this .vcf.gz. Of course, if you do it like this, let's just format it well. So if you do it like this without the -c1, that means you are going to get that number that came, the 92 something. That's what you are going to get. So if you want the variant themselves, then you'll have to bring your -c1. So that one, the decision is up to you. So you have to decide what you want. All right. So let's do this. For this one too, let's just say .variants.vcf so that we are consistent with the naming. So you can execute this command also to do the subset for that particular sample. So these are all approaches you can use. Let's do an ls, and you'll find that also there. We have that here. That one was NA21124. Yeah, that's also here. So you can count and verify. All right, so that's how it is. So this is how we split or subset VCFs. Now you notice that all the files have been saved in the current working directory. All right, this can be problematic. All right, especially if you are going to generate lots of files, and especially where you're also going to generate different kinds of files. All right, so it's advisable to organize your files as you go along. So let's say, for example, the script we executed, we got these files. We gave it this name .variant.vcf.gz. We can put that output in another directory so that we get the files organized. So let's do this. So let's create a directory. Let's say make the, and let's say extracts. All right, let's just give it this name, or let's just say variant extracts. All right, now we can move these files there. So we can say mv star dot variant.vcf.gz. Now, why am I doing this? For the output, we give this name. So this name here, this extension here, runs through all the outputs that were generated when we executed our script. But the other ones, too, we had a different naming convention for it. All right. So we can move them there. Of course, this we generated using the script. And this one too, it was the same activity, but we run the command separately. So we can put all of them in that directory. All right, so that's what we are going to do next. So we are going to move all those files that we extracted, the true variants, we will move them to the variant extract that we created. So that's what this command is for. So let's move everything there. So I'll say variant underscore extract. All right, so when you do an ls, you will see it here. All right, let's just clear the screen and do it again. Let's do an ls. We will find our directory variant extract, and we ls into it. You are going to find your files, your output files. All right, so you can do it this way. Alternatively, in the script itself, let's edit it again. So nano extract variants. All right. Alternatively, in the script, you can create a directory and then you save the output in that directory without you having to run the scripts and then creating another directory again and then moving the files. You can do it here in the script. So let's even try that. So I'll modify the script. So I'll say make the, and maybe I can say subsets. I can even give it this name. It's fine. So any name of your choice. And then when I come to this side here, all right, I will say subset slash, and I will specify the rest of the information, the same thing. So nothing changes again. It's just this directory that I have created and I have introduced here. That's it. So now let's exit, save the changes, and then let's run the script again. So I'll say dot slash extracts underscore variants. So let's run it and then see what happens. So we are processing the files one by one. Okay, so the files have been processed. So let's do an ls. We are going to find the directory subsets. And then when you ls into it, let's ls, you can find your files there. All right, so that's how it is. You can also do this. Let's add up. If let's say you want the count for the variants, you can also do that as well. So we can even edit the script again. So I can say nano extract variants, and then I'll add something else to it. All right. So I can say, let me just add this. I can put something else here. I will just display it by the way. So I can do this. I can say BCFTOOLS view. All right, this time I have generated the file. So I can just say, I can specify it here. All right. And then I bring my grep. And then I can say grep dash vin dash c. I bring my pattern here like this. And then that's it. So let's exit and save the changes. Of course, now I've created the directory and everything. So you may see some message telling us that the directory has already been created, but that's fine. That is not important now. So I can execute the script again. All right, and then the files will be processed. All right, so when they are processed, you also see the counts being displayed for you, the variants, number of variants. All right, so that's how we do it. So with this script, you can add a lot of stuff to it. If you want to add some statistics to it, you can do that. And you can also save these numbers to a separate output file You can even save it to a CSV file that you can view using a spreadsheet software and other stuffs. All right, so you can do lots of things when you have this kinds of automation done. I repeat, you can do lots and lots of things if you're able to automate your pipelines like this. All right, so that's how we do it. Now this one, it says cannot create directory subset file exists. This is because we had earlier on created it, all right, in the script. So because we did not remove it, bash knows that it's there, so it's telling us that the directory is already there. So this one is fine. All right, so this is how we split or subset VCFs. Now we have generated the VCFs, but it's also important to learn how to generate those VCFs in the first place. I repeat, it's important to learn how to generate the VCFs in the first place. So that means you have to watch my videos on variant calling. After calling the variants and generating the VCFs, it's also important to learn how to perform variant annotation. So variant annotation can help you to know the effects of these variants and all those stuff. So the playlist that's being shown here will let you know how to call variants and also how to annotate your variants and how to perform variant effects prediction.